Very good morning. Welcome to my class, System Modeling and Simulation. The model number 1, Introduction to Simulation. Today we are going to discuss about the components of a system and model of a system and its types and discrete and continuous systems. So now we'll see the components of a system. In this components of a system, we have entity and attribute. That these two things is the main important one. So entity is nothing but an object of interest in the system. Or we can say, and then attribute is like it's a property of an entity, we can say. So for example, bank. If you are going to study the bank, then customer is an entity. So if customer is an entity, then withdrawing, deposit, and so these are the things which is an activity or properties of the attribute. So this is one of the best example for this components of a system, and one by one we will see. Entity is an object of interest in a system. Example, they have given a factory system, and departments, orders, parts and products, these are the entities. For example, departments, if departments is the study, if you are going to study the department is an entity, then there are systems, number of systems or number of computers, we can say this is an characteristics or properties of the entity. So and next is attribute. Attribute denotes the property of an entity or characteristics of an entity. Example, they have given quantities for each order, type of part, or number of machines in a department, or these are the attributes of a factory system. So activity in the sense it represents a time period of specified length. Example, manufacturing process of the department. For example, we can say the inter arrival time of the customers and service time given by the service to the customer. So that we can say a good example for this activity. So here they have given a specified length, time period of specified length. So example, manufacturing process of the department. And state of the system. So the state of the system is defined as a collection of variables or interaction with the variables, we can say, and it is necessary to describe a system at any time relative to the objective of study. An event is defined as instantaneous occurrence that may change the state of the system. For example, if you are in a system, if you are in a stable system, if any other events which is occurring simultaneously, then we can say is an event that may change the state of the system too. So otherwise we can say it is a system environment. And endogenous is used to describe the activities and events occurring within a system, and exogenous is used to describe the activities and events in environment that affect the system. So endogenous means the events which is going to occurring within your system. Exogenous is nothing but which is going to affect your system. So these are the components we can see. And now we will see the discrete and continuous system. So discrete system, what is the difference between the discrete and continuous system? For discrete system, a good example we can say is a bank, and continuous system we can give a good example is a dam, water dam. So first we will see the discrete system. This is the one which the state variable change only at a discrete set of points in a time. So I have given an graphical representation mode for this discrete system. For example, in a bank, so the arrival of customers for each and every 6 to 8 minutes, there is an arrival of customers to the bank from 9 to 4 p.m. so that the customer arrives, and the service which is given by the server to the customer varies a lot. So that we can calculate. For example, the customer arrive to the bank, and afterwards he is going to stay the bank at 1, and then after finishing everything, then it is under time 2. So this is the only change at a discrete set of points in a time, we can say. So in between that particular time, in between that particular set of points in a time, the customer is going to get serviced from the service in the bank. So from 9 to 4 p.m. So this is one of the very good example to the discrete system. And the bank says that the state variable, the number of customers in the bank, changes only when the customer arrives or when the service provided a customer is completed. So these two phenomena is a very good example for the discrete system. So the number of customers waiting in the line. that is under time based on the customer arrivals only. So the arrival of the customer and service given by the service to server to the customer, these two things we can calculate at only at the discrete set of points in a time. And continuous system. Now continuous system, it states that the state variable changes continuous over time. So for example, we can say head of water behind a dam. During and for some time after a rainstorm, water flow into there is no any particular direction like north, east, west or south. There is no any proper particular directions. It can flow as it is. How the rainstorm, after a rainstorm, how it is based on that the water flows into as it is directions. So this is one of the very good example for the continuous system, head of water behind the dam. Now we'll see the model of a system. Model is nothing but, we can say it is a graphical representation of the system for the purpose of studying the system. So model, we can assume the model of a system in various situations. For example, mathematical model and physical model and heuristic model, etc. So it is necessary to consider only those aspects of the system that affect the problem under investigation. So we can go for what if questions to predict the to predict the process of our new design systems or new design process, to know the behavior of the system and to test the system, that to get a clarity how the system is going to work it on. And this model of the system is expressed in terms of mathematical, logical and symbolic representations of often objects in the system, so that it is going to act as a design tool as well as the analysis tool. Analysis tool in the sense we can easily predict the previous existing system behaviors and all. We can easily predict how effectively the changes happens in that previous system. And then if it is going to act as a design tool, where it's easily to analyze the performance of a new design process. So these aspects are represented in a model, and by definition it is a simplification of the system, we can say. So these are the types of models. One is mathematical or physical model, static and dynamic model, and deterministic and stochastic model. So these are the types of models. So types of models we will see: mathematical or physical model. Mathematical model uses symbolic notation and equations to represent a system. Here this mathematical model is using mathematical derivations or mathematical equations to represent a system. For example, traffic signal. So if the vehicle is going under the traffic signal, either it is a green color or in a red color. For example, if the green color is under the mass length of 100, and then red signal is under the mass length of 150, like something. If vehicle is arriving on the road, so if some other vehicles are crossing the same on the road, simultaneously we can easily calculate by using the mathematical derivations which we can taken from the traffic signal. So that is one of the very good example for the mathematical mathematical equations. And static model is like it represents a system at a particular point in a time, and we can also call this as Monte Carlo simulation. So the static model, we can also call it as a Monte Carlo simulation. And dynamic simulation model represents a system as a change over time. Simulation of a bank from 9 to 4 is a very good example for this dynamic model. So because once the customer arrives to the bank, they are not going to stay back in the bank, so they will finish their works and they will go back. So simultaneously we can there are changes over time we can see in the dynamic model. But in static model it's not like that. It represents a system at a particular point in a time, and it's also called as a Monte Carlo simulation. So these are the types of models. Once again, we will see mathematical or physical model, static model and dynamic model. And deterministic model, this contain no random variables. It has a set of known input which leads to the unique set of output. So this is the deterministic model. Here there is no any random variables which we can see in this model. And but in stochastic model we have one or more random variables as input, and random input leads to random output. Since the output are random, they can be considered only as estimates of the true characteristics of the model, we can say. So main thing we need to understand is deterministic and stochastic model. In deterministic there is no random variable. In stochastic model we have one or more random variable as input, and random input leads to random output. These outputs are randomly, they can consider only as estimates of the true characteristics of the model. And discrete event system simulation. So the model of the system in which the state variable changes only at the discrete set of points in a time. We already discussed this in previous slide. Bank is a very good example. So bank is a very good example for that discrete system. That is the arriving of customers and service which is given service giving to the particular customers at a particular point of time. So the simulation models are analyzed by numerical rather than by analytical methods. So analytical methods employ the deductive reasoning of mathematics to solve the model. For example, differential calculus can be used to determine the minimum cost policy for some inventory models. So these differential calculus, when we can use to solve, if the problem is going to solve analytically or mathematically or any physical methods, we can use to determine the minimum cost policy for some inventory models. Inventory models we'll see in forthcoming sessions. These inventory models will calculate through budgets or funds which we are going to get. Based on that, we can use a statistical models to analyze that. So once again we will see this discrete event system simulation. The model of a system in which the state variable changes only at a discrete set of points in a time. For example, we can say it's a bank. From 9 to 4 p.m. There are so many customers which is going to bank, and they are going to get serviced by the server. That is we can based on a particular point of time only we can calculate, and the simulation models are analyzed by numerical rather than by the analytical methods. Numerical methods use computational procedures and are more runs which is generated based on the model assumptions and observations are collected to be analyzed and to estimate the true system performance measures. For example, runs in the sense we can say it is a productions. For example, if you are going to model a new design system, before that we have to make sure that we need to analyze the problem formulation or problem analysis. So then afterwards we can go for the overall project plan of the new design process. Then afterwards simultaneously we need to get a user experience abstract and as well as the conceptualization methods. These two things will work together as it is without interrupting or without affecting with each other, and then it will be going for verification, validation, and then it's after finishing everything it is going for experimental design, and then afterwards we'll get a runs. How much runs we can get? If enough runs means we can directly go to the documentation or implementation part or testing part. Otherwise we can again go for the experimental design part. So experimental design is the most significant one in the simulation concept. So if we need more runs or if we need more production, then we definitely have to go for experimental design, so that we can get a proper design methodologies. So these numerical methods use a computational procedures and more runs which is generated based on the model assumptions. Model assumptions in the sense we can apply any modeling techniques based on the conditions, based on the situations, and observations are collected to be analyzed and to estimate the true system performance measures. And real world simulation is so vast, whose runs are conducted with the help of a computer. Much insight can be obtained.